Hello, everybody. That's a pretty good crowd for a 4:45 p.m. session. I myself am feeling a little sleepy, and thank you for coming in to save some money. And that's our intent. I hope some of you have. Cannot hear me?
Same volume up.
Volume up? All right. Usually I can speak even without mic and you can hear me. I thought with microphone I should slow down a little bit. I will make sure you guys get it. So hopefully some of you at least have attended the previous session, which is kind of like a little bit more of a deep dive onto hyperscale. Here we are taking a kind of like a different track. It's not just hyperscale. What is the best way to cut down your cost on SQL DB, right? We'll take many different tracks, look at numbers. This is less technical, more bean counting, more money, right? Who's ready to save some money? All right. My name is Abdul Sattar Seth. I run the product management team for SQL DB in Azure. I probably have the best product management team in all of cloud computing. That's why we have the best products too. I have with me Nils. I'll let Nils introduce himself.
Sure. Hi, I'm Nils Pullman. I've been working at, we can flip to the bios if we want to. Working at Microsoft for 27 years, been through a variety of different product teams, big data, SQL, experimentation platforms. Very excited to be working on Azure SQL Database now with Abdul.
Thank you, Nils. And I didn't put up my slide. Sorry about that. So if you want to see how I look like before I got all this gray, that's how I look like. So before we really get started, I want to have some show of hands on how many of you are actually running on Azure Cloud. Oh, that's pretty much everybody. And SQL DB? Excellent. And how many of you are thinking or feeling that you are just spending too much money on the database? I don't know if we really need this session. I think everybody is happy with where they are. Why should we cut down our revenue? So why optimize database costs? Anybody give me just your reason for why you want to optimize database costs.
I can run more with the same money.
Great.
My CTO doesn't come back next year, so I exceeded what I asked for.
Excellent. Anybody else?
Clients have restricted budgets.
I'm sorry?
Clients have restricted budgets.
Oh, great answer. Anything else?
Justifies my salary increase.
That's a great point too. Please.
I had a Snowflake rep say that they could do the same thing that we could do on Azure for half the cost. So I have a hard time believing that, and I wanted to get some actual numbers.
Now you can take these numbers and show the Snowflake rep and ask him to cut it down by half, and it'll be really difficult.
Okay, good.
So, you all know this better than me that Microsoft is a very customer-focused company, right? We love our customers, and just like when a director directs a movie and gets it out in the theater, of course, the director makes money and the producer makes money, but in addition to that, they get a satisfaction when they see that the audience really loving that movie, right? The theaters are full, and there's good reviews about the movie because it's a creative effort. So if you think about software and services, it's not very different, right? All of us work very hard to produce what we produce, to get it to you, to make money for us and to make money for you. But the real thing that actually gets us excited is when we see the customers really loving what we put forth for the customers, right? They're making very good use of it to run their business. And customer usually gets happy for one of two reasons, or a lot of times both reasons. One is the product is awesome, the features are wonderful, it's doing what it is supposed to do in the best possible manner. Two, it's not really costing them a whole lot, right? So that's exactly why everything we do, we try to reduce the cost on our side so we can pass on the cost savings to you. And then there are a whole bunch of things that we have done in the service in many different places that we want to provide you as a way to cut down costs for the database service. And in many of these, we feel that many of our customers probably don't know about it or are not using it really well. So that's why we thought we'll put together a session where we exactly walk you through what all are the possibilities to cut down the cost. So here is kind of like the blueprint for doing this. The first thing I would suggest everybody does is categorize their database. This is important for many different reasons. I have Rajesh here, who is my GeoDR PM. We wanted to do a series of blogs or sessions later on resilience. How do you bring the best resilience to your databases? But the resilience need for all databases is not the same. Your tier 1 production versus dev is not the same, right? That should apply to the cost of these things as well. So the first thing I suggest is you categorize the databases based on the criticality, scale, and performance needs, and then choose the right service tier to fit your database strategy. We have a lot of different service tiers, right? We'll go into the details of it. So it's important to pick the right service tier that fits best for the category of the database you have. And then there's a whole bunch of configuration that you can do to optimize the overall footprint of the database as well as optimize the cost of the database. And then comes the additional fine-tuning. We'll go into this as we go through the slides. And then, obviously, get all the possible discounts you can get on the database that you have, right? So how do you categorize the database? This is kind of like an industry standard. Some people start with mission critical. Some people start with tier 0. Some start with tier 1. Tier 1 is your most important database. That's usually customer facing, and if that application the database is serving goes down, your business loses tons of money. So if you're a bank, this is the application your customers are using to deposit money, withdraw money, or transfer money, interbank transfers, all that kind of thing. If you're an e-commerce shop, this is your front end where customers come in your shop, where customer comes in to buy stuff from you. There'll be a lot of other applications which are powered by other databases that you use internally. For example, your HR application that you use to pay your employees, right? It's not the same criticality as your e-commerce shop. Because if your shop is down, you're not making any money. If you are going to be a day late in paying your employees, not very good, but your company doesn't fall apart, right? So this is the kind of like a normal categorizations of the database, tier 1, tier 2, tier 3, which we normally considered as critical production database. Then there is low tier production databases. You could have a lot of departmental applications and home built applications in the company. All of them needs to use a database. They all kind of like fall into the low tier production. Then there is dev test. When I say dev test, it's the unit test. So you are developing an application hooked up to a database, then you need to do the unit test on this same database. Very low in that pecking order, right? And then comes the integration test or performance test, UAT. People have all kinds of different environments, right? So when you do integration test, the integration test environment has to match the production environment. Otherwise, something would work, but when you go to production, it won't work. Same thing when it comes to perf test, right? To actually do performance test, it has to match your production environment. UAT the same, and then a lot of customers have what they call either gold or debug or that kind of environment. which will be an exact replica of the production. So when something goes wrong in production, they can do debug in this environment, not exactly in production, right? So it's the criticality is not high, because if that is down for some time, nobody really cares a whole lot, because you can bring it up or create another copy. But the performance characteristics should be the same as your production. Please feel free to stop me anytime to ask questions. I'm really bad in doing that, So instead of me keep asking you, anybody has questions, just raise your hand or just shout it out. All right? So it's a little too small for me to read, but I hope you guys can do it. So this is the characteristics of each of these databases based on the categorization we did, right? So if you go for tier 1 production, we need that is the databases, or those are the databases that you want the highest performance on. This is the top tier database that is serving your top tier application. What is the usage profile? This is going to be up 24/7. It cannot go down, right? And the database size usually is kind of like large, and the definition of large varies from customer to customer. You need scalability, both horizontal and vertical, because it's a critical database, critical application. Your business could go through the roof because something went viral, so you need to scale up quickly. Or you have a whole bunch of ancillary applications now, you need to be able to scale horizontally. And because this database actually makes you money, it's so critical for your business, you're willing to pay well, or the cost profile is not too much of a concern for you, right? And then comes the disruption tolerance, which is basically RPO, RTO. What is your disruption tolerance? How long can this database be down? So your tier 1 database, usually people cannot tolerate more than a few seconds of downtime. Now that changes as you go towards the right. It goes from seconds to low minutes to high minutes to hours, and goes like that, right? So you'll see for every tier, as we go from left to right, these characteristics change from highest performance to high performance to medium, low, that way. So the kind of service tier that we pick should match the kind of database categorization you have. Any questions there? I remember to ask you. There you go. Just want to call this out. So if you look at overall Azure SQL, we call all of this as Azure SQL, right? Which is running Azure on VMs, which is IaaS. You launch some VM, bring up whatever version of SQL Server you want in it, you manage it. That we call it SQL VM, Azure SQL VM. Then we have Azure SQL Managed Instance. And we are today here talking only about Azure SQL Database, which is the full PaaS multi-tenant database service, right? Just want to make it clear so that we don't have any confusion going forward. Now within this Azure SQL Database tier, we have 5 different service tiers. There are actually 7, but 2 of them kind of like are together in architecture. So this is, I kind of like slice this up based on the architecture and how exactly they work. One is called the business critical, and there's another thing called premium, the same architecture, just the way we price them is different. It is, then there is hyperscale that Arvind and Aditya told you all about, which Aditya has kind of like made me a believer that it's the world's best database. Then now we have hyperscale serverless for hyperscale. Then we have general purpose and standard. Again, architecture is the same. There are 2 different business models. And then we have the general purpose serverless. Business critical or premium uses, I probably need to take a step back and also tell you this. business critical and premium are not very different from how you used to run your databases on-prem, right? We have added a lot of optimization on top of it, a lot of management, a lot of automation, but underneath it is the same architecture, how you would run on-prem. So these databases use local SSD storage. Because it's local SSD storage, you get blazing performance. You get awesome performance, very low latency because the storage, the SSDs are right there. But the problem is if that node fails, then your data is gone. So to prevent that from happening, what we do is we do a 4-way replication, synchronous replication. So the business critical has actually 4 databases that are continuously being synchronized, right? I would say this is actually a great candidate for your tier 1 and tier 2 applications, production applications, because of the performance, 1. 2, the resilience. The 4-way replication gives this awesome resilience. And then you can actually also take those four copies of databases that you have, you can distribute across 3 availability zones. So you get zone redundancy as well. And the zone redundancy also included in the price. So you don't have to pay anything additional for it. And then I told you there are 4 instances or 4 databases that are being continuously replicated. One of these databases is available to you as a read replica. So you have some horizontal scaling as well, right? So for whatever you are paying, these things come free. They are included. You get your whatever vCore database you are asking for, plus you get a read replica, plus you get zone redundancy or multi-zone distribution. Just from that picture, from the diagram, you can see this is probably not the most efficient architecture from a cost perspective, because we are replicating it in 4-way, right? So the cost is very high, and we obviously pass on the cost to you, so this is expensive, but you get the best performance and the resilience with it for the cost that you are paying. Now, one issue or one limitation business critical and premium has is, one, the max storage is limited at 4 terabytes. You cannot go beyond 4 terabytes, right? Now, it's not just 4 terabytes, because it uses local SSD. If you are, let's say, you want to run a 2 vCore database and you want 4 terabytes, we give you 4 terabytes, we have no more terabytes left in that box to sell the rest of the 78 vCores, right? So we kind of like tiered up or have constrained how much database storage you can get per the vCores that you are using. So if you want to, let's say you want a 3 terabyte database, you have to get at least 12 vCores. Your workload might need only 4 vCores, right? The actual workload you have only needs 4 vCores, but because you have 3 terabytes of data, you are going to have to pay for 12 vCores. And I have, on the right-hand side, I have kind of like a price for this. 2 vCores is the minimum you can get for business critical. It costs $1.35 per hour, and the storage is 25 cents per gig per month. And the second one is general purpose. General purpose architecture is very different from the business critical architecture. General purpose uses remote storage. Because it is using remote storage, this is the same Azure storage that you can go get from Azure for your own other purposes, right? So these are pretty well distributed. Azure storage that we use for general purpose actually is distributed across 3 different nodes. That means there is 3-way redundancy, right? 3 copies of the same data. The possibility of this getting corrupted, all the 3 of getting corrupted, is very, very low. So we have persistence, pretty good resilience and persistence with the remote storage itself. So we don't need to do additional replication. That gives it a really good cost profile, right? Just one remote storage, and we are good with the persistence. But the problem is, The previous one, we had local storage, which gives it really blazing performance and very low latency. Now you have to go over Ethernet to the storage cluster, and the whole bunch of things that the storage cluster has to do. They told you the storage cluster actually is 3 nodes, and it has to write in all the 3 nodes and make sure it is written before coming back to you. That means performance degradation, right? So comparing GP to business critical, GP's performance is going to be much lower than business critical. But because of the single node architecture, we are not doing 4-way replication, single node, remote storage. That also is less expensive storage. We can keep the price of general purpose much lower. Business critical was $1.39, and general purpose is only 50 cents per hour.
Was I thinking of something else, or is there some like local ephemeral storage for like temp DB?
There is local ephemeral storage. All of these nodes come with local SSDs as well, right? So we use local ephemeral storage for TempDB. So we could use the remote storage for TempDB as well, but that will additionally affect the performance. So for that, we kept it this way. Now, this also is limited to 4 terabytes. You would think, why would you have 4 terabyte limit if it is remote storage? The local storage, yeah, you have only 4 terabyte SSD, so you have to limit it there. Why 4 terabyte limit for GP? That is because of restorability. It's a size of data operation, right? Size of data operation to a remote disk, bringing all the 4 terabytes of data to restore, if you need to restore from a backup, would take a very long time, right? Anything more than that kind of like gets into the territory, it's not acceptable anymore. So we have capped that at 4 terabyte as well. Just like business critical, here also we have kind of like constrained the storage you can get based on the vCore count that you have. Oh, I forgot to mention this about business critical. Business critical, this is all running in actual physical compute nodes, right? So if you are business critical, let's say you got a 8-week or business critical, now your need went up, you want to upgrade to 16-week cores, right? So you will do what we call an update SLO, to go from 8-week core to 16-week core. Now when you try to go from 8-week core to 16-week core, we actually have 128 80-week cores or 128 week cores in that box. You are not the only one who is running in that box, right? We have provided enough isolation and fencing for all of you, but you are not the only one who is running in that box. It is possible that there is another 8-week cores or 12, 16-week cores sitting empty that no other customer have used yet. In that case, we can actually increase your week cores from 8 to 16 and pretty quickly give you a 16-week core business critical, right? But when you ask for a 16-week core and we don't find empty 16-week core in that box, we'll have to move you to another box, right? If we have to move you to another box, that is a size of data operation because of local SSD. So if we need to do those kind of things, it is going to take time. It's not quick. Whereas when it comes to general purpose, because it is remote storage and a single node, we can just detach the storage, bring you a 16-week core from somewhere and just reattach, right? So the upgrades and downgrades are quick in general purpose. And you probably also noticed that the storage is much cheaper for general purpose. It is 25 cents per gig per month on business critical, and it's only 11.5 cents per gig per month for general purpose. Now, all of these things add up, right? We have, many of you might be running, tens or hundreds of databases or thousands of databases. We have customers who are running hundreds of thousands of databases. When we look at the trajectory, it looks like in a not very far date, they will probably hit 1 million databases, right? So when you are looking at that scale, everything matters. even if you save like 10 cents per database, when you have 500,000 databases, it makes a huge difference, right? Now, some of you might be running a lot of databases. Some of you might be running a small number of databases. But I'm pretty sure you'll be running a lot more databases in the future with us. So it's a good idea to start thinking about right now. All right. And then hyperscale. What can I tell you about hyperscale? Arvind and Aditya told you everything about hyperscale. They just kind of like stole my thunder. To kind of like put it simply, I'm in love with hyperscale for one simple reason. That simple reason is what I started this talk with, is that the business critical and general purpose service tiers that we have, they are architected not any different from how you were running databases in your data center, right? Like I said, we add a lot of automation, management, and all that kind of nicer things on top of it to run the service at scale, but it's not any different from how you were running it on-prem, either four-way replication or a single node with a remote storage. In other words, what that means is we are not really making use of everything the cloud has to offer, right? When you were running databases on-prem, you were not running on cloud. You are running in the old data center technology. So in a way, I have seen when Tesla came up with an electric car, those guys, because they didn't have anything before, right? This is the first car they were building. They didn't have an ICE car or a gas-powered or diesel-powered car before, so they didn't have any baggage. They went to the drawing board and designed that car to be fully an electric car and released it in the market, became a hit. You know the rest of the story. And there are a lot of other big car manufacturers already. Ford and Mercedes and BMWs of the world. So many of them, right? And they already had the technology. They already were building cars. They know how to build cars, but they were building ICE cars, not electric cars. So what they thought was, we know how to do this. We'll pull out the engine, we'll put an electric motor and fit in a battery to power it, right? It's not the same thing. And a lot of these guys built a lot of those kind of cars and brought it to the market. All of them failed. People didn't want them. It is a gas car retrofitted with electric motor. So if you think about our GP and BC architecture, it's kind of like similar. What we are doing is we are taking the same old architecture that everybody was running in the data center and adopted it to run on the cloud. It works, it has been very successful. It helped a lot of customers, but it's still not getting the real, juicy stuff that the cloud has to offer. The pure elasticity, the scalability, and the cost saving that come from it, and all that kind of stuff, right? That is the thing I love about hyperscale. Hyperscale is architected to be a cloud-native database. Anything that you can think of as a property of the cloud, we have embedded that into hyperscale. You can have, Arvind told you can have up to 30 read replicas, right? And these read replicas can come and go. It all depends on your workload, how you want to configure it. You can, in business critical, you have one read replica. In hyperscale, you can have 30 read replicas. Not just you can have 30 read replicas, the hyperscale primary compute node itself can have 4 high availability replicas, right? So now it is 30 plus 4, 34. And then I believe each read replica can have 4 HA replicas, right, Arvind? That is 124 replicas. I don't know what you will do with 124 replicas, but it just shows you the horizontal scalability, right? What is possible. And you can have HA replicas that go into different availability zone, giving you zone redundancy. You can have zone redundancy in general purpose, What we do when you opt for zone redundancy in general purpose is we'll put your primary node in one zone, and we'll put a secondary node in the second zone, but you have no access to that secondary zone node. That's only for failing over. That means you cannot have a read replica, though you can have some zone redundancy, right? We have been doing a lot of testing internally to see how hyperscale matches up with business critical in performance. Because one thing we talked about was for tier 1, we want to have the highest performance, right? For business critical, memory optimized, we found it to perform equally or better than business critical. So you have the performance, you have the zone redundancy with 4 HA replicas and up to 30 named replicas, and you can go up to 100 terabytes. And the best thing is there is no constraint on your database size based on your vCore size. You can have a 2 vCore database with 100 terabyte storage, right? Whatever your need is, because of the loose coupling between the storage and the compute, we are able to do it. So in a way, if you think about it, what we have done here with this awesome architecture is took the best things from hyperscale, best things from business critical, and the best things from general purpose, and brought that properties into hyperscale. And of course, the upgrades, the slow upgrade going from 2 vCore to 4 vCore or 8 to 6 vCore or 16 vCore, it's all pretty much instantaneous. All right, so this is an exciting slide. So what I did was I kind of like put together some pricing for all these different tiers that we talked about, right? I don't have the pricing for dev here. I'm just talking about the production tiers, because before we go to the dev pricing, we have Nils is going to walk us through some other exciting stuff. So these pricing I did based on what I recommended would be the best service tiers to use for each one of those categories of database, right? Now look at the tier 1 production. I'm going here with a 4 vCore database with 500 gigs of storage, which is, you would think that will be kind of like a typical database that most customers use, 4 vCores with 500 gigs of data. So if you look at the first one for tier 1 production, I have side-by-side business critical and memory optimized hyperscale. That is what I would recommend to use in place of business critical or for tier 1 production. And you can see the glaring price difference right there, right? 1956.96 for the 4 vCores of business critical. But for memory optimized hyperscale, it's $737.28. It is less than half, right? Now, this is the new price. Question for you.
Oh, you just answered it. I was about to ask, is it the one we had this morning?
Yes, this is the new price. So what we.
To get on discount, so I thought maybe I could get another 35%.
So what we did here is basically we did away with the licensing part of it to make it more kind of like modern cloud-friendly pricing. So if you think about business critical and general purpose, just like I said before, is the same old architecture as on-prem, right? So we are not changing anything there. Same old on-prem architecture, same old on-prem kind of like pricing style, which includes IP and everything. So people who have license, they can bring license, use it here, and use it the way they were using before. Now, if you think about hyperscale, this is not something you can do on-prem. You cannot build a hyperscale on-prem. It's built very specifically for the infrastructure that we have here. So it's a very cloud-native database, so it gets a cloud-native price. It's something that we have been discussing for a while, and finally we got the opportunity to bring it to you. So if you just quickly look through that pricing, I told you the storage is 25 cents per gig, so 500 gigs, $125. It is the same for hyperscale as well. It's 25 cents per gig. That's $125 for 500 gigs. And zone redundancy, business critical, because it has 4 replicas already, you can get zone redundancy without any additional cost. You just check mark a box, they get placed automatically into 3 different availability zones, and you get zone redundancy, $0. Whereas in hyperscale, you are getting only 1 instance, right? Only 1 database, there's no replica. So if you want zone redundancy, you need to get a replica. You need to get an HA replica. So that is going to cost you the same as your primary. So that's why I have the other 737.28 there. And then you shouldn't run your tier 1 production database without geo redundancy. You know, the possibility of an entire region going down is pretty small, but believe me, I have seen it. At the scale we run these things, you know, there are so many things that go wrong on an hourly basis, you don't even know, right? We auto-mitigate all of these things. Then there are these big, huge things that happen that we don't have control on, and then, you know, everything goes down, right? So because tier 1 and tier 2, especially tier 1 database is something that your business depends on, and you cannot afford more than a few seconds of downtime, you need to have zone redundancy. So if a data center goes down, which has happened many times due to overheating or generators blowing up or power outage or whatever else, then we automatically fail you over to the other data center or to the other availability zone. Most of the time you wouldn't even know because it's so quick.
Given that and the fact that there's no increase in cost in the business, why is that not default? Because you actually have to select zone redundancy.
For business critical? Yeah, we want to make it default. We actually have been preparing for that for some time. We have some customers who are like, you know, gaming customers, right? For them, latency is very, very critical. So when you go multi-AZ, your latency goes up a tiny bit. It'll go up from 1 millisecond to 2 milliseconds, because now it has to go a little farther, right? We are doing synchronous replication, right? So now for these customers, you know, they will be concerned, so we don't want to automatically do it, right? So we are doing it in phases, in different regions for different customers, we keep doing it. Once we reach a saturation point with the existing customers, then we'll make it default. All the new business critical will be multi-AZ by default. So now for geo-replica, it is going to cost you the same as the primary, because it's another database with the same configuration, with the same storage on the other side, right? Look at the cost difference. You are getting the same performance or better performance than business critical. You are getting all the niceties of the cloud native architecture, and it is costing you pretty much half of what you would pay in business critical. Now let's look at tier 2. Now tier 2, again, you know, business critical will be the right thing for you to go with. Everything pretty much remains the same, except I have changed. Now, you know, these are all, I'm just giving you examples, right? A lot of these will change based on what your requirement is, how, you know, critical you think a particular database is, right? Maybe this particular database is not really tier 2, it's tier 2.5, and you decide you probably don't want GeoDR, right? So I'm just giving you an example so you can work these things out. Now in this case, you'll see that geo-replica is only half the price of the primary. That is because our dear friend Rajesh here today launched a new thing for GeoDR, where if you use a standby replica, where the replica that you have for GeoDR, you are not going to read from it. It is just for failover. We continue replicating to it. You are not going to read from it. We will fail over, you know, if something happens to the primary. We call it, you know, standby replica. So if you opt for standby replica, you don't have to pay for license on it. You just pay for the compute. So the price goes down. There again, you know, this kind of like a, not 50% difference, you know, probably like a 35-40% difference between the business critical and hyperscale. Now here, you see the hyperscale prices are lower than tier 1, right? So hyperscale, the primary is only $527, whereas in the tier 1, it is $737. Who can tell me what it is? I just want to see who is awake.
Memory optimized.
Exactly. So the first one is memory optimized, which is priced higher. The second one is just plain simple hyperscale. It could be PRMS or it could be Gen 5, same price. So that comes to $1,831, and the business critical comes to $3,083. No brainer, right? So if you are just going with pay as you go, this is how you buy databases, this is no brainer. Hyperscale would be the right way to do it. Now let's go to tier 3 production. The interesting thing about hyperscale is you match it up with business critical, you match it up with general purpose. You know, it'll fit in everywhere. You just need to pick the right configuration, right? So here I picked the hyperscale, not memory optimized, for the tier 3. And we don't want geo-replica. So these configurations that I'm doing here is based on a previous slide that I had, right? Where for each tier, what is the configuration that we want? What is the RPO, RTO we want, and all that? So here there's no geo-replica. So there's no geo-replica storage either, but it has zone redundancy. So hyperscale, it comes to $1,179, whereas for general purpose, it comes to $1,105, right? Small difference. General purpose is slightly cheaper. But if you go with this configuration for another, how much? Like $170, you're getting a whole lot more with hyperscale, right? But there is something that I overlooked when I did this first time, that, you know, I told you when you go to, here we have zone redundancy for general purpose, right? But I told you when you do zone redundancy for general purpose, you are not able to read from it. It is just for failover, right? Whereas the HA replica for hyperscale, you can read from it. That means when you go 4-week or 4-week or in hyperscale, actually you are getting 8-week or to do transactions, right? 4-week or for the primary and 4-week or for your HA replica. Whereas in general purpose, you are getting only 4-week or. So I thought, what if we do the other way, where we scale down hyperscale by 50%? Even if you take a 4-weeker of hyperscale and a 4-weeker of general purpose, hyperscale performance is going to be so much higher, right? Just because the hyperscale performance is pretty much equivalent to business critical performance. So you're getting a lot more performance. Now you're getting another 4-weekers as named HA replica. So we can actually safely cut it down, scale down the hyperscale. So if you do a 50% scale down, that is the last column I have for tier 3. So I'm going with a 2-week-or hyperscale instead of 4-week-or hyperscale. So you get a 2-week-or hyperscale and a 2-week-or HA replica. And you can send all your read workload to the HA replica. That'll take, so a typical database is 80-20, right? 80% read, 20% write. That's kind of like a, it goes up and down a little bit. So now if you can send like half of that read workload to the HA replica, you'll have plenty of juice left in your primary node for all the write operations and the rest of the read operations, right? So if you do that, now your cost falls down to $652, as much less than general purpose. So I'm doing similar thing for low tier production as well. There I dropped the zone redundancy too. No zone redundancy. We have hyperscale, general purpose, and hyperscale at 50%. Hyperscale at 50% is 50% of general purpose. Even regular hyperscale at the same 4-weeker. In this case, there is no zone redundancy, so no HA replica. Because no HA replica, you probably want to stay at 4-weeker, so you can do week-or matching and you get much better performance with hyperscale. Even in that case, the price comes down. It's lower than what you'd pay for general purpose, right? All right. Now I'll hand it over to our good friend, Nils, to tell us some exciting stuff about what you can do for dev databases.
Great, thanks a lot, Abdul. Yeah, so starting off, this is the year of copilots, and I don't quite have the 3 decades of wisdom that Abdul has, so I figured I'd start with the new Azure Copilot and ask him about how they could how it could help optimize my costs here. So I asked, and this was announced this morning. So if you haven't seen it yet in the portal, it's pretty cool and fun to play around with. So I want an Azure SQL database where I only pay for the compute that I use. And the Copilot came back, and it told me the thing you want is serverless. So that's one of the things we're going to look at here for this dev test scenario. So serverless is one of the compute tiers, and it's available in 2 different service tiers, in hyperscale and in general purpose. So when we think about the dev test tier, we're thinking about sort of applications where you're still just developing things, or it could be line of business apps like an internal expense system or a content management system that is only getting used periodically. So serverless is a great option for these, and let's take a look at how it can save you some money. With serverless, there's sort of 2 main knobs that you've got to control the scaling. There's the min and the max values on how many vCores and the corresponding memory, and that's going to help with determining sort of your maximum costs and minimum costs. And then the second thing you control is the how long after the database activity stops does the database go into sort of this auto pause mode. And so that's I think set at an hour by default. And so once it goes into that pause mode, those resources are able to be reclaimed, and so you're not being charged for those. So you get that's a savings that gets passed on to you with serverless. So in the billing, you can see that you're only getting billed for the vCores and the memory you used. Yep. Yes.
I was just curious, is there any plans to reduce it from an hour?
Yes, great question. Yes, they're working on it. Arvind, do you want? Yeah, they're working on it. Soon? Yeah. As soon as possible. Yes, we get that question frequently, so I know it is actively being worked on. Yeah, so in this graph visualization of the database over 24-hour period, you can see the number of vCores ranges between 1 and 8. And so that's another way that you're saving as you're scaling up and down how many vCores are being used. And this the serverless option, this is the same great fully managed PaaS database. So all of the goodness of high availability backups, all that you get with serverless. And so then just thinking about the serverless usage patterns, like when does it make the most sense? Well, one obvious case is if you have a new database and you don't really know what the usage pattern is going to be on it. And so you want to just actually have a system that's going to scale up, scale down very easily, and you don't want to go through paying for provisioning a lot of resources that aren't going to get used. And then if you know that the database is going to be used on an intermittent basis, that's another great opportunity to consider serverless. There are some scenarios where provisioned is obviously better. So if you are running the database constantly for the whole month, that's going to end up provision will be a better deal for you. But if there's let's say like it's only half of the month that it's being used, and there is a pricing calculator, so you kind of have to play around with some of the options here, some of the assumptions about like how many vCores you're going to be using on average, because they're going up and down. So there's a little estimating you have to do on this. Also with serverless, there is some performance trade-offs related to the scaling and changes too. So those are all sort of considerations for serverless. But for that dev test where you're just starting out, great thing to consider. And we now have in public preview serverless for hyperscale, for Abdul's favorite database, and should be your favorite database too. So this can go, scale all the way up to 100 terabytes. And just looking at some of the numbers on this, sort of more of the same assumptions here. You've got this very low per vCore second cost with serverless, and so compared to if you look at some of these sort of average workloads, you're going to end up coming out ahead on serverless. So so that's just to summarize on that. The workloads with intermittent usage, easy, cost-effective way to scale up and down. Definitely give serverless a look. So then the next question I had for the new Azure Copilot was, well, what if I want a database that actually allows me to develop for free? And this is a common request we get, because even if you're an existing customer, you may need to start a new database for a proof of concept. Maybe you don't have budget to get that new database. You just want to be able to develop for free. And gosh, wouldn't it be great if Azure SQL had an option for that? Now we've had free offers in the past, but they were on some of those lower basic models of Azure SQL, and so we're happy to announce that, and the Copilot has already figured this out. We have a new free tier now on Azure SQL Database. So let's go take a look at that. With this new free offer, we've got a chance for people to experience SQL Database, build on it, and it's got, unlike the previous offer, which expired after 12 months, this one renews your free amount of that serverless vCore seconds every month. And so this is not a database that's going to go away at some point. It's a great way to start out and renew monthly. So the offer is, what you get for free is 100,000 vCore seconds per month. And so then the first day of the next month, you'll get that amount again. 32 gigs of storage, backup storage. It's serverless. This offer is good for the lifetime of the subscription. And the constraint is you get one of these databases per subscription. So it's a much more generous offer than the previous one, and it's really the best way to start with serverless. And so you may be wondering, like, this 100,000 vCore seconds, like, what can I do with that? Is that enough? So it's really going to depend on your scenarios. You could use a little bit for the entire month, or you could dial up the vCores and run through it faster. You have that option with those serverless min and max settings. And so just, question over there.
Get some sort of a warning when you get close to your limit, if you go over.
Yes, I'm gonna. Question was, do you get some sort of a warning? And I'm gonna show you how to get that warning. First, I'm gonna. Got a few slides ahead. So yeah, so just one of the other learnings from the past officers, free offers that we had is it wasn't always easy to find these. So I'm just going to start out on the Azure.com. There's many free offers in Azure, and some of them are of the 12-month variety, and some are of the always free variety. So you'll see this new Azure SQL offer is of the always free variety. So when you go to the Azure SQL page on Azure.com, you'll see the banner here. You can click through, and you can learn about this, this new offer and how you get started on it. So, and if you already are a customer and you've got your account on Azure, and this is good for any type of Azure account, by the way. The old offer used to just be the free account. So you can use your enterprise account, and you can go ahead and check out this offer. So let's take a look at how you get to this offer. So here we are in portal.azure.com, and so when we start up, look for a new SQL database. On the provisioning here, now you'll see there is a new pink banner and opportunity to apply that offer. You'll see that the cost summary card on the right will go to 0, reflecting that the offer has been applied. And so you go ahead and create the database. Now there's a setting here about do you want, at the end of your free amount, do you want it to just pause for the rest of the month, in which case the database won't be accessible, or you could continue for additional charges. I'll tell you a little bit more about that in a minute. Yeah, when you're starting out here, one constraint is you can't restore your existing databases to this free offer. It's really intended for new databases. You can use the sample database if you're playing around with something new like GitHub Copilot. So yeah, so this is the how you find that offer. It's just a few clicks, and you should be able to create your first free database. So moving ahead, so what does this database look like compared to general purpose serverless tier? If you look on the overview page, it's very similar, but you'll see now in the pricing tier, you'll see it says free in there. And that's and then now you'll see the vCore amount, how many seconds you have remaining for the month. And there is monitoring here where you can look at the free amount remaining, free amount used, and you can actually also set alerts on that. So if you want to have it alert you when you've got 10,000 vCore seconds left or something like that, you can do that too. So let's take a look on the compute and storage tab. Here we have the free offer applied. You can see that you can change between 1 and 4 vCores. That changes the corresponding amount of memory. And you've got that 32 gig size max database. Now, if you decided that you want to be charged at general purpose rates, once that free amount is expired, now there's basically all the general purpose serverless is unlocked for you. So you can go all the way up to 80 vCores and 4 terabyte database size. So this is a really easy way to start out and then to start scaling up. And because you get that free amount every month, it's kind of a no-brainer for starting with it. Yes.
Just by looking at this portal, I think it's not there yet, but you plan to, I want to move this to a business critical from the free.
It's playing there. Let's see. Maybe I can pause that. But yes, if you want to move to a different tier, you can turn the offer off and you can move to BC. So that is an option that you've got there. continuing on. So yeah, so just tips for like how to make the most out of your free amount. Yeah, set the alerts. This is the answer to your question, which is basically you decide when you want to get an email about the free amount hitting some threshold, and so that'll help you sort of plan your month. And there's also some other little tips. If you leave tools like SQL Server Management Studio open and the database is open, it will be using some amount of vCore seconds. So close those tools so you don't go away on Friday, come back on Monday, and you've used up a lot of your free amount. And then reducing the auto pause time to 15 minutes. It is coming soon, as mentioned earlier. So yeah, and there's lots of great guidance online on the serverless documentation about how to optimize your autopause behavior on a serverless database. So serverless is a great option. The free offer is a great way to get going with serverless. Start today, aka.ms/freedb, and you'll get underway there. So then just to wrap up here for the dev test comparison of the costs. So after that free database, like let's say that so you can pick if you pick hyperscale, there's some assumptions about with serverless about how often the database is being used. So in this case, it was 50 hours a week, or 33% of the max possible usage. So you can see in this scenario here, you've got some considerable cost savings coming from serverless. So yeah. So with that, we're going to hand back to Abdul, and he's got even more ways to save.
Thank you, Neil. See, you win. I just wanted to tell you folks on how to save money on your bill, how to cut down your cost. And my good friend wanted to give it for free, right? Actually, the free offer that Neil launched with the serverless was one of the launches that we had most excitement in the community. Like so many people, that kind of like tells me that a lot of people haven't really tried serverless yet, right? So one of the things to keep in mind when it comes to serverless is a great thing to put to use for dev test kind of like workloads. So if you remember the table that I had for different categories of database and different characteristics, one of the things that I had there was utilization. For the tier 1, it was 24/7. For tier 2, it was 24/7, right? So when it comes to dev test, the utilization I had was 10 by 5. That's 10 hours a day, 5 days a week, right? That's how most of the developers work. They normally don't work on the weekends. And usually 10 hours a day on the weekday. So that makes it 50 hours. Now, what is 50 hours compared to the total hours in a week? 168 hours in a week. 50 hours is less than a third, right? So to get the real benefit of serverless, you need to be in that range, about like 30, 35, 40%. And then within that, you get variance, right? When a developer is using this database with his application, it's not always at that 4-week core. A lot of times it's going to be at half-week core, or 1-week core, or 2-week core. So that variation and the 1/3 or less than 40% utilization gives you that best number. So there's something, I actually was digging through it a couple of days ago. I came across this, was very exciting for me, so I just want to touch on this. One thing I really loved about hyperscale serverless, thank you, Arvind, for giving me all the details, about hyperscale serverless is you can have hyperscale serverless as one of the named replicas in a provisioned hyperscale. So you have a provisioned hyperscale database, and then let's say you have a provisioned hyperscale with one HA replica. You are doing your reads and writes and everything, and then there is this weekly or bi-weekly report some department runs on your database that actually just brings your database to a halt. You send them to this named replica that is based on serverless. Go from 2 to 16 vCores or half to 4 vCores, whatever. It scales up depending on whatever that report is doing. Once it is done, it scales back, and once we have pause, it just goes to sleep, right? So creatively think about all these kind of like different scenarios that you have in your organization, and come up with the right configuration and right tier to save money.
Is the hyperscale serverless generally available, or is it still free?
Yes, it's in public preview. Yes, yeah, it's available for everybody to use, but not GA yet. It'll be GA pretty soon. So this, if you attended Arvind's previous session, he covered this a little bit. Oh, okay. Elastic pools. Elastic pools is a great way to save money. I mean, a great way to save money. Arvind didn't say this, emphasizing it's a great way to save money, because we have a lot of customers. We have been doing a lot of digging and analyzing numbers and stuff. We have a lot of customers who have cut down their bill by like 60%, 70% by switching their databases to Elastic pools. So the way Elastic pool works is you are actually distributing the resources, right? It's kind of like what you have in there. In your dorm room, there might be 6 people in that dorm room. It becomes kind of like congested if they are all there together, right? So if whoever allocates people in that room allocates in such a way that usually there are only like 2 people there at the same time. 2 people have a night shift, 2 people have an early morning shift. 2 people kind of like, sleep in friends' couches most of the time and show up once in a while. Now you have a good balance, right? It is not crowded, and it is pretty inexpensive for every one of those 6 people. So that is what happens in in Elastic pools. So you need to know what your workloads are, right? So basically what you do is you take a bunch of databases that might not be active at the same time, doing a lot of stuff at the same time, right? Let's say if you're a SaaS provider, you have a bunch of databases that belongs to some customers who are in Singapore, and a bunch of databases that belongs to customers in the US, some in East Coast Canada and things like that. Their peak time is very different, right? Once you mix them up, let's say you put 25 of these databases together in one Elastic pool, only like 5 of them are really active at a time. And when some other one comes up, these kind of like slow down, right? So it kind of like balances out. And what we are talking about is, let's go to the next slide. So here you have 8 databases, right? Let's say these 8 databases you are using general purpose. So for standalone singleton database, for general purpose, you are using 2 vCores for each one of those databases, because 2 vCores is the smallest you can get for general purpose, right? Sometimes they do need 2 vCores, but not most of the time. So you cannot get anything less than 2 vCores anyway, because sometimes they need 2 vCores. And how many vCores are you going to spend on these 8? 16 vCores, right? So you're paying for 16 vCores. And then you figured out, oh, actually they're not all active at the same time. Let me put into an Elastic pool. So you get a 4 vCore Elastic pool and put all the databases into that 4 vCore Elastic pool. And you are saving money on 12 vCores. Right? That's like 80% saving, right? It all depends on how you calibrate that. And we have customers who kind of like use it to the fullest extent. I was really surprised how customers use it. So in business critical, there is a limit of a maximum of 100 databases per elastic pool. You cannot do more than 100. That also is constrained on vCores. In general purpose, it is 500. You can have 500 database in an elastic pool. I have seen elastic pools with 380, 400 databases. Don't ask me what they do, but they figure out what is the right distribution, right? Some of these are production databases. They mix up production and dev together. So dev databases are not busy all the time. Some production databases are busy, some not busy. So they figure out what is the best way to do it and then pack them together. And this could save you a ton of money. Questions? Oh, I'll wrap up quickly. I mentioned about hyperscale elastic pool. Another place to look at for savings is backup cost. A lot of people don't look at this. There are two places where you can reduce your backup cost. One, we have many different kinds of backup storage. You can see the price right there. LRS, ZRS, RAGRS, RAGRS being the most expensive one. And we have RAGZRS also for long-term retention. You don't need the most expensive backup storage for all the tiers. Why do you need RAGRS for dev test, right? So I have a table right next to it that kind of like gives some recommendation on the type of storage to use. And then for Peter backup, you can have up to 35-day retention, right? When you say 35-day retention, we are continuously taking backup of the log, and we are taking backup of the data few times a day. So it really adds up, means your storage utilization keeps going up. Yeah, you would really need that for tier 1 and tier 2. But for tier 3, tier 4, maybe not 35 days, maybe 7 days is okay. For dev test, maybe 3 days is okay. So pay attention to all these kind of things. We have, especially for LTR, we have some customers who pay hundreds of thousands of dollars because they're very transaction-heavy databases, right? It's not just the size of the database, right? It's the data that is changing. So when the data is changing, we keep taking backup. So the more often the data changes, the more storage you are using for backup. The more storage you are using for backup, more money you'll be paying. Then we come to hybrid benefit. So does everybody know about hybrid benefit? Who doesn't know what hybrid benefit is? Okay. So if you have purchased any SQL Server licenses, right? Not for Azure, you have purchased SQL Server licenses previously to use on your on-prem databases, and then you have purchased what is called SA. What does SA? Software assurance. That costs about 25% of the license. So if you bought software assurance, then you can bring those licenses to Azure. So I told you, we just removed the license part from hyperscale, right? The rest of the stuff still has license part, right? Business critical and general purpose. So if you use this hybrid benefit, that'll drop your cost, and it'll drop your cost substantially. So look at there. So 2 vCore general purpose, the regular pay-as-you-go price is $505, that's 50 cents, 50.5 cents. And once you apply the hybrid benefit, it drops to 30.5 cents. You'll see even a bigger difference in business critical. Business critical pay-as-you-go price is $1.359, and the hybrid benefit price is 60.9 cents, right? Huge difference, like 55% difference for business critical and 40% difference for GP. And this could make a huge difference. So if you have licenses, this is something you definitely need to make use of. Now, 1 minute, I'll come to you. I showed you a slide before, which I was very excited about, that looks like hyperscale wins every time. You go to hyperscale, you get the lowest price, half, 1/3 compared to BC and GP and things like that. My session is not about telling you should always buy hyperscale. My session is to tell you how to save money, right? So I'll show you some slides next. We are at time, so I'll go really quick. Once you apply a hybrid benefit and a reserved capacity, sometimes hyperscale is not the cheapest. So it depends on what you have, where you are coming from, what kind of database you have. So work these things out. And then even for dev test, sometimes serverless might not be the best fit because you cannot apply a hybrid benefit to serverless. No hybrid benefit on serverless. And you cannot apply hybrid benefit on hyperscale, right? Because it doesn't have any license component. You can apply a reserve capacity discount on hyperscale, but you cannot do it on serverless. That is the reserved capacity discount, and that is pretty awesome. So if you look at the general purpose, the reserved the pay-as-you-go is 50.5 cents. Hybrid benefit is 30.5 cents. You combine both of these, it becomes 13.7 cents. Hybrid benefit plus reserved capacity, right? It drops from 50.5 cents to 13.7 cents. You do same thing in business critical, it drops from $1.359 to 27.4 cents. That is like 80% savings. Huge, really, really big savings, right? The last column that I have there is, I kind of like made that up a little bit because we haven't published the new price of hyperscale yet. That is the new price, that will be the new price of hyperscale when we have a 3-year reserved capacity. So the regular pay-as-you-go price, the new price, right? The new regular pay-as-you-go price for 2-week core is 36.6 cents. And you do a 3-year reserved capacity, it drops to 16.5 cents. Again, huge difference. But there is no hybrid benefit in hyperscale. Now let us apply all this to that same table and look how things look like. I was surprised when I applied all this. Lot of times you see hyperscale either better, coming close, but not like before. Do you remember in tier 1, when I initially did it, business critical was $3,000 some. And hyperscale was like 1,800 something, right? It was less than half. Now that has changed. Now, actually business critical is a little cheaper than hyperscale. But even when you see something is a little cheaper than hyperscale, I'll still wholeheartedly recommend you to go to hyperscale because that is the future. That is the best architecture you can get. So this should open your eyes. In some places, the difference is really staggering, even for serverless. So do your homework before you decide what you want to buy and what you want to get on. So that is what I would like to close with. Most optimization roads lead to hyperscale. When we got started on working on hyperscale, this was the goal: business critical performance at general purpose price, and we tried to stay to that as true as possible. And I think we pulled it off. You are getting a really, really good scalability in every aspect of the database, really awesome performance, and a future-proof architecture. So these are the sessions from tomorrow. This is the last session, and thank you for being patient with us, and thank you for staying so late. Some references, and thank you for both myself and my friend here.